Hey guys, welcome back to Genius Learning. And so I want to show an example from the previous video on rotational motion and how to use some of the equations we learned from linear to rotational. So it says here a rotating circular table starts from rest and then rotates through an angle of 480 degrees in 2 seconds, experiencing constant acceleration. Before I start anything, I just want to highlight things that when I read, I look at and just make sure I understand. A rotating circular table starts from rest. So when I see something that starts from rest, immediately I highlight it. I might need it later. And rotates through an angle of 480 in 2 seconds, that's fine. Experiencing constant acceleration, that's also important. All right, so an angle of 480, we know that a full circle is 360, and then we have another 120 to go, leaving us around there. So we're gonna go one full circle like that. Okay, and then we're gonna go 480, which should be somewhere around there. That's where we stop. Okay, so this is 480 degrees. Okay, and this motion is going to be in this direction here. Okay, so it went through 480 degrees in 2 seconds. All right, and so now they're asking us, what is the angular acceleration the table experienced during that time? So remember that the angular acceleration is going to be alpha. So that's what they're asking for, and we have an equation that we can use, right? So we're gonna use so I'll put it here. Let's see, we have here theta final is equal to theta initial plus omega initial times time plus 1/2 alpha time squared. Okay, so this right here is what we're going to use. All right, so what do we know? That at rest, theta initial is going to be 0. And at rest, also omega initial is going to be 0. Right, so now we're just left with theta final is equal to 1/2 alpha time squared. All right, and we know all these values. We know theta, we know the angle that it went through, we know the time that it took, right? So we rearrange this. We have alpha is equal to 2 theta over time squared. Okay, so let's hold that here for a second, and we definitely need to understand how to convert from degrees to radians, because you can't have your answer in degrees. So we know that, okay, so we need to learn how to convert. Okay, so now we're going to use 480 degrees, which is what we have, right? And we're going to multiply it times, let's see, we're going to multiply it times pi radians over 180 degrees. So notice how this is the same thing. So you're basically multiplying 480 times 1, because pi is over here, right? And 180 is also over here. So they're both the same thing. So we want to cancel out the degrees, and we want to be left with only radians. Okay, so this is how we convert. Okay, so we're going to use this, right? And we're going to place that right here in place of theta. So we have alpha is equal to 2 times, we have 480, let's see, 480 degrees times pi radians over 180 degrees, and all of that is divided by time. squared, right? So that's going to be 2 squared, which is just 4. So here we're going to be left with the 2 on the bottom. Okay, so this should be, I'm not sure, let me see, I don't have my calculator, but so we have a 2 on the bottom. This is 480. I'm gonna say this is gonna be close to, let's say 4, 19 rads per second. Again, just check that because I'm not sure that that's the correct number, but I mean, this is the correct setup. So now we're gonna move on to the final angular velocity. Okay, so final angular velocity is this, right? And so we have an equation for that. So we have here omega is equal to, which is omega final, is equal to omega initial plus alpha times time. Okay, and let's see, let's box this up. Okay, and let's see, we got here omega final is going to be equal to omega initial, which is 0, right? Because we started from rest. And so all we have is alpha times time. And so we have alpha equals 4.19 rads per second. Okay, and the time it took was 2 seconds. All right, so here we're gonna have rads per second squared, sorry, the units. And so we're gonna cancel out one of the seconds, and omega final is gonna be 8.38 rads per second. Okay, give me 1 second, let me get a calculator. Okay, let's check this number here. We're gonna check this here. So we have 2 times 480. So 2, actually we have here a 2 on the bottom, so we're just gonna leave that there. We're gonna do this top part here, which is gonna be 480 times pi, and divide that by 180. Okay, so, and then we're gonna divide that by 2. So yeah, we get 4.19. Okay, and so then this number should also be correct. All right, perfect. So this is how we calculate our angular acceleration with the equations that I showed in the previous video. All right, relating the linear motion to the angular motion. And here we got the final angular velocity. So we just calculated this table here rotating from rest. It's just spinning, and we can calculate the angular acceleration that it's been given and the final velocity that it's going through. So let's say like one of those casino, gambling, I'm not even sure what they're called. And so they rotate like that. We can calculate when it's gonna stop, right? And how fast it was being spun at in order for it to go 180 before, it stops, or going through 180 in 2 seconds. So we can calculate things like that. And I'm just trying to relate it to something in real life you might know. So that's how you do that. Guys, please subscribe if this video was helpful, and comment below if you want to see any particular examples. All right.